Okay, so good day to our students who are watching for today's video. Okay, so this is the ninth lesson for our topics in the third quarter. So we have the law of sines and the law of cosines for problems involving oblique triangles. So what we're dealing with are triangles that do not have any right triangles in them. Okay, so let's try to solve and jump right ahead with this problem. Okay, so the problem reads, use the information in the diagram to determine how much closer you live to the music store at point C than your friend's house. Okay, so we have this map, okay, and your home is at point A at 81 degrees. Your friend's home is at point B at 65 degrees, and they form a triangle with the music shop at point C, both connecting at point C at 34 degrees. So just based on this diagram, what type of triangle is this? Is this an SSS, an SAS, an ASA, or an AAS triangle? If we try to look closely, we have two angles and an included side. So therefore, just by looking at the definitions, this must be, okay, so this must be a side angle side. Oh no, so this must be an angle side angle triangle or an ASA triangle. Okay, so if this is an ASA triangle, what are we going to use? The law of sines or the law of cosines? So for the law of sines, we have to use ASA or the type of triangles that can use the law of sines are the ASA and the AAS type of triangles. And for the law of cosines, we can use the SSS and the SAS. Since we have an ASA triangle, therefore we can use the law of sines. And what does the law of sines state? So it states that sine A all over side A is equal to sine B all over side B is equal to sine C all over side C. And for this given problem, first we can try to solve for the measurement of side B and side C using side C, since B is missing and side C is given. Because if we're going to use sine B, so this gives us sine B all over B is equal to sine C all over C. And what's the value again of sine B? So that's 65 degrees. So this is going to give us sine of 65 is equal to B, which is missing. Okay, sine 65 all over B is going to be equal to sine C. Okay, and sine C is equal to what? Okay, so sine C is equal to 34 degrees. So that's sine of 34 all over the value of C, which is 1.5. And if we try to cross multiply this proportion, this is going to give us 1.5 sine of 65 degrees is equal to B sine of 34. Since we only want the value of B, so we have to divide both sides by sine of 34. There you go. Okay, and if we divide both sides by sine of 34, this cancels out. And therefore the value of B is just equal to 1.5 times sine of 65 all over sine of 34. And if you use our calcu, let's see what value will be given to us. So this is going to give us 1.5. Let's try to use our calcu. 1.5 times sine of 65 all over sine of 34. And that should give us approximately 2.43 miles. So therefore the distance of your home to the music shop is 2.43 miles based from this given diagram. We still have to solve for one more value, so we still have to solve for A. So this was solving for B. Our first part was solving for B. Now we have to solve for A. So let's try to solve for A for our second problem. So solving for A, we're still going to use the same formula. the law of sines. But this time, we're going to use a different value. We're going to use sine A and sine C. Okay, so why not use sine B? We can use sine B, but again, B here, it's quite close to the right, to the exact answer, but it's still an approximate answer. So if we want the best or the most exact answer, we have to use, or we have to partner A with C. Okay, so that's going to give us sine A all over A is equal to sine C all over C, since our value of C is given. So this is going to give us sine of 81 all over A, the side that we're missing, is equal to sine C, okay, sine of 34 all over 1.5. And again, using cross multiplication, so this is going to give us sine 1.5 times sine of 81 is equal to A sine of 34. So since we don't want a sine of 34 on the right side, we have to divide both sides by sine of 34. Now this cancels out, and therefore the value of A is just 1.5 sine of 81 all over sine of 34. And if you try to evaluate that using your calculator, so that should give you 1.5 times sine of 81 all over sine of 34. And if you look at your calculator, so this is going to be the output. There it goes. So if you try to, put that equation, so there you go. You're going to find the distance from your friend's home to the music shop is 2.65 miles. Okay, so not quite much of a difference. So if the distance of your friend's home to the music shop is 2.65 miles, okay, and there's 81 degrees, and the distance from your home to the music shop is 2.43 miles. What are they asking from this problem? Okay, we need to determine how much closer you live to the music store or the music shop as compared to your friend. So we just simply have to subtract the value of A and B in order to get the difference for this one. So therefore the difference is equal to 2.65 minus 2.43, which is equal to 2.65 minus 2.43. So that should give us 11.50 or 0.22 miles. Okay, so that's around some 100 or 200 feet there, or 300 feet. So therefore your house is around 0.22 miles. Okay, the difference of the distance between your friend's house and your house for the music shop is 0.22 miles, which is around 200 to 300 feet distance. Okay, and that's how we can use trigonometry to solve real-life problems. And let's try to go to our next lesson, or some more problems involving oblique triangles.